All right, well, good afternoon and welcome to beautiful, rainy Seattle. My name is Ted Wei. I'm a program manager on the Microsoft Azure Machine Learning team. And today we'll be talking about going from Hindsight to Foresight, integrating Azure Machine Learning with Excel, using an Excel add-in, and showing what you can do in terms of machine learning, integrating that with Azure ML on Power BI. So as I mentioned, I'd like to know how you feel. So go ahead and tweet. If you want to tweet about how you feel, we're going to be doing a demo on sentiment analysis. And you saw this morning in the keynote that for a quick sentiment analysis on just some Facebook data. And so we'll be doing the same on tweets from this conference. And so you'll be able to do that too. And for those of you who are watching this on the live stream, the great thing about this is you can do this too. So feel free and go ahead and tweet how you feel. Could be about what you had for breakfast this morning, how you feel about the person sitting next to you, how you feel about the conference so far. And so, again, those on the live stream, please also play along. If you're actually watching a recording of this and you're binge watching sessions from the summit, that's kind of cool, maybe kind of not, but I'm flattered that you're binge watching this rather than Breaking Bad. But all right. So, in terms of the analytic world today, we see a lot of different roles, and they can generally be grouped as these types of roles. And so just to get an idea of who's in the audience today, could you please raise your hand if you consider yourself an analyst? All right, cool. A lot of analysts in this room. How about a data scientist, if you consider yourself a data scientist? OK, great. A couple of those. And how about developers? Ooh, OK, lots of developers. That's great. As you know, and as you've probably lived through already, these roles are highly interdependent. You have a very, very important job to do. You need to make sure that the right data is being collected, the right transforms are being applied, the right joins are being done, the right insights are being generated that need to go to the right people so that they can make the right decisions. Very, very difficult job, very complex. And sometimes what happens in these roles is you end up finding yourself in silos. Believe me, I work at Microsoft. I know silos. I know what happens. So what's the solution? Do we create some SharePoint list that everybody has to sign off on before anything can get done? Do we make another attempt at being better and communicating with each other? I think it's about expanding your skill set. I think it's about learning new things. And so as an analyst, you're no longer an analyst. You're an analyst who can do some data science with some of the tools I'll be showing you. You're no longer a data scientist. You're a data scientist who can take the model that you built and put it and run it into production. You're no longer just a developer. You're a developer who can create solutions and do deep analytics based on that. And so usually when I talk about machine learning, people fall into two general buckets. There's the people who are super excited. There are people who are like, OK, bring it on. Tell me more. How do I do this? And then there are the people who might be feeling a little anxious. What is this new world of machine learning? How will I be able to get the skills that I need? How do I add value? So I was reading on Quora the other day that if you're feeling anxious, it's OK. It's actually very hard to calm yourself down if you're feeling anxious. However, anxiety and excitement are much more similar than anxiety and calm. So I would challenge you, if you're feeling a little anxious right now, turn that anxiety into excitement. Join the excited people in this room, and then let's talk about machine learning. So now that we're all properly excited, let's talk about some of what I want to do today. So I want to talk about an Excel add-in. I want to be able to teach you how to use it. So while those of you who are doing email right now, you can go ahead and fire up Excel. We'll be using that in a little bit. For those of you who aren't doing email, feel free to grab out your laptops. We'll be doing some stuff in Excel. We'll be doing some stuff in the browser. I see a couple of Macs around. It's OK. It's OK. You can use those too. Just fire up your favorite browser. We'll be talking about the Excel add-in and Azure Machine Learning for predictive analytics. And the main takeaways, really, are things that you obviously already know. First one is to nail the last mile. Are people familiar with the last mile term from telecommunications industry? Yeah, so basically it's the connection from all that great infrastructure. Right? You can imagine your Verizons, your Comcasts, lots of great connections to the internet backbone, and lots of high bandwidth stuff going around. But if that doesn't go to your house, it's essentially useless. So sometimes what we find ourselves doing is we build these great models, we do all these great things, but if they don't get to, if you don't make that last mile connection and they don't get to your end user, it's essentially useless. So that's something to keep in mind. Second thing is to go native with the natives. Maybe you write in R, maybe you talk in Python. Maybe you do a lot of other things that the people who are actually consuming your insights, they don't speak. And so that's why we're all here, to talk about Excel, Power BI, how you can go native with the natives and be able to show them insights in a way that they can actually consume. So how does this apply in real life? Let's say we were an elevator company, and the ask that you get from your boss is, how do we make sure our elevators don't break down? Okay, so as analysts, as data scientists, people working in the analytics space, our job is to tell stories with data. So what story will you tell? And actually, how can you tell a better story? Now, we all work for an elevator company, pretend, and we're going to tell stories about elevator components. And for those of you who are snickering in the audience, may I remind you, you paid money to come to a conference whose main attraction is Nate Silver. So there's a lot of snickering going around right now. But what story will you tell, and how can you tell a better story? So let's talk about what kind of stories you can tell. This is one of my favorite slides from Gartner. It talks about the value of going from hindsight to foresight. So at the left hand of the graph is really what a lot of people end up doing, descriptive analytics. What happened? The story you tell is essentially what happened. OK, so we're an elevator company. Pretend this is July. It's about 3 months from now. And the report that we get is an elevator broke down, trapping 10 people at the conference, preventing them from fulfilling their lifelong dream of seeing Nate Silver in person. That's what happened. OK, how about going up the value chain a little bit? Why did it happen? All right, so now everybody's starting to dig into their data and joining data sets together, because joining data sets is cool, and you start finding out, oh, it turns out there was this component that broke down. It was supposed to be replaced in 2 years, but for whatever reason, it broke down. This component broke down, causing the elevator doors not to be able to be open, preventing 10 people from achieving their lifelong dream of meeting Nate Silver in person. So that's why did it happen? How do we get from hindsight to foresight? How do we start telling a story of what will happen? And this is where machine learning comes in. And so we work with a company, ThyssenKrupp. They make and maintain elevators. And they have sensors on their elevators that they're sending to a machine learning model. Every couple seconds, we're getting data from all their different sensors, and we're predicting whether something will break down. And now you can start telling a more powerful story. What will happen? Well, based on this data, we predict that this component is going to break down in the next 5 days. It's not due to be replaced, but given the data, we predict it's going to break down. And ultimately, that can help you tell the most powerful story. How can we make things happen? Because we predict that this elevator component is going to break down in the next 5 days, we're going to send a maintenance crew to go fix this elevator. And now these 10 people can go up the elevator into the conference room and meet Nate Silver in person, fulfilling their lifelong dream and ambition. What a powerful story. How can we make things happen? So, going back to all the tweets, how we're going to do this in real time. If you have your browsers out, feel free to go to this URL. So just go to it. This is going to take you to an Excel online workbook. I'm going to populate it with data right now based on your tweets. So if you could just go to that URL and don't open it yet, but give me 1 second. Okay, so I'm going to copy over all the tweets that were just tweeted in the last few minutes. I'm going to copy it over to to this sheet. OK, is everybody able to see? Let me just double check real fast. Are people able to see the data in this workbook? OK. Let me know if you're able to see this right now. So you should be seeing this if you go to aka.ms/xls sample. So aka.ms/xls sample. All right. So let's do sentiment analysis on all the tweets that were basically tweeted in the last 2 days of this conference, up until the tweets that you just sent a couple of minutes ago. So in this case, you should be needing to add this Excel add-in. It just comes with a sheet. And so anybody who receives this sheet will be able to have this add-in. All you have to do is just click on it, the text sentiment analysis add-in. And what we're going to do is to do sentiment analysis on this tweet text. So you can just watch what I'm doing. Select column C and just select basically all this text. And then click the selector button here. Click OK. And we're going to put the output into D1. I'm going to run predict. And what's happening now is all these strings are being sent up to an Azure Machine Learning service that's been pre-trained to do sentiment analysis on English. And basically, you can see these responses. And with these responses, you can now do a lot of interesting things. You have all the power of Excel now to look at sentiment over time. So let me get that. So you can see here, for the most part, tweets have been amazingly positive, which is great. Over the last couple hours, the number of tweets peaked at around 8 o'clock. And then it started decreasing from there. I think we had a lunchtime lull over here. And then we can probably see the data of the things that you had probably tweeted right now. So you can look at this stuff kind of in real time. If you're launching a new product and you want to do sentiment analysis on all the tweets that are coming out for your product, you don't have to hire people to do that. You can just do sentiment analysis on that. And then you can drill in to see what kind of things people are saying. Maybe you can look at top users. Who are our most positive and negative people? So this might be interesting for the organizers of the conference to come down and look at, OK, who are our most positive people? Let's identify them. Let's help them amplify the message. Let's look at who our most negative people are. And these people might be interesting to go talk to and just help them understand why they might be feeling what they're feeling. And so these are just ways that you can apply machine learning. And so for those who went along with this, thank you very much. I really appreciate it because there's a few reasons. There's a few reasons why I want you to just go through this with me very, very quickly. One is just to see how easy it is to be able to send an Excel file around, have the add-in already part of it, and be able to do sentiment analysis immediately. The second part is, as a program manager of this feature, I really appreciate you helping my download statistics. So if you could download it a couple more times and ask your friends to download it, that'd be great. So what's behind these web services? What's behind all this machine learning stuff? And to do that, and to answer the question, I'm going to do another demo. And this time, we're going to ask the question, would you board the Titanic? How would you go about answering the question of, would you board the Titanic? So to do that, we're going to create a machine learning experiment. We'll have links here later on. But if you were in the data science talk, that Danielle did earlier today, you saw the machine learning gallery. This is the Cortana Analytics gallery. So just like when you open up an Excel workbook, you see a lot of templates. You see something like that here. So if you're interested in machine learning experiments, things like how would you do online fraud detection, how would you do retail forecasting, lots of different examples here that you could start playing with. Corn yield, futures price prediction, anomaly detection. We're going to do something to predict survival rates on the Titanic. So in this case, I'm just going to click on it, and I can open this in Studio. This is the Machine Learning Studio. This is how you can build a machine learning experiment and then be able to publish that as an API that then you could use. And again, these are just a lot of templates that you can play with, so you're not starting from scratch. You can use Studio for free. You can use it as an anonymous guest. If you have a Microsoft account, you can still use it for free. You can just use it for a little bit longer. But you can start out in the gallery, and what I'm doing now is opening that experiment inside the Studio. And if this is going to take a little bit, I have the experiment open already. In this case, what we're going to do is build our first machine learning experiment. So the question is, would you board the Titanic? So what kind of historical data do we have? Well, we have Titanic data. So let's take a look. Right here, we have data that might be interesting and data that might not be. So we have their passenger ID. We're doing supervised learning, so we can see here that in our data set, we have about 549 people who did not survive, and we had 342 people who did. We had what class they were in, whether they were first, second, or third class passengers, what their name was, gender, age, etc. So in this UI, you can just drag and drop different modules here to process the data. So here I have my Titanic data set. I'm just dropping some columns, such as passenger ID, that I know it's not very useful. I'm just renaming some columns, replacing all missing values with a median, and just doing some basic processing, pre-processing. But you can do this pre-processing anywhere else if you want, but you can do it in here. And this is where we do the machine learning, where I'm splitting the data. In this case, I'm going to have my training set and my test set. So in my training set, that's what I'm going to build the model on. Because sometimes what ends up happening, or what will end up happening if you only build a model on your entire data set, is overfitting. So you can build an amazing model that would do great on this data, but if you try it on unknown data, it will not perform very well. So we're going to split the data. Our training set's going to go here into the train model, and I'm using a 2-class boosted decision tree. So in here, and why we call it experiments, is there's a bunch of different classifiers that you can use. If you want to do 2-class decision forests, if you want to use a neural network, if you want to use a support vector machine, that's totally cool. And so you can just switch it in and out right here if you want to use that classification algorithm instead of this one. So these are a lot of things that you can just do, and then you could, and you could just experiment and see what gives you the best result. So once you run this, I already ran this experiment, but once you run it, it just takes a minute and a half or so. All this data is being processed. We're building a model, and now we can look at the results of the model. So in this case, you see an ROC curve. You see the accuracy, precision, area under the curve, just basic data points that could help you decide whether this is a good model or not. If you don't like it, you could just switch it out with a different classification algorithm. For those of you who do R and Python, we also have an execute R and execute Python script module. So you could just drag that in here. And in here, you can write your R code. And then what happens is the data will just flow in, and that R code or a Python script will run. And that's one of the things that we've been finding. If you're already doing some machine learning, if you're already doing some data science in your organizations today, what ends up happening is you have a data science org that's basically doing all its modeling, and it's doing a lot of great stuff, but they show you, and it runs perfectly on their laptop. How do you actually operationalize it? How do you put it into production? And so the data science team talks to the dev side of the house and gives them different things, and then some things might get lost in translation because the IT people talk a different language and they host it in something else, and then 2 weeks later, the data science team has an improved model that needs to get updated, and everything just becomes a big mess. So in this case, whatever you publish, even with the R and Python code, will be the thing that is run in production. So now if we're finishing, let's say we have a model that we like. Again, we're trying to predict survival rates of Titanic passengers. So we're going through here. I can just set up a web service, a predictive experiment. What happens here is now I have a different experiment, and this is one I'm going to put in production. Everything's already done. And I have my web service input now. This is the input that's going to go in, and then this is the input that's going to, and then it's going to flow through the same process, and it's going to run that trained model that I just built. So now, this is how I can build a machine learning model. And now I can deploy it. So this is, again, where data scientists before who might have needed to rely on the IT side of the house can actually put an API into production hosted on Azure. This doesn't mean the IT department is obsolete. This just means it makes life easier for everybody. You now have an API. Here's an API key. And this is just hosted on Azure now. So I have a RESTful API. This is the URI that I can call. Now you can imagine I can start building some apps that could call this URL. And now let's see how we can use it in Excel. So going back into Excel, if you want to play with this yourself, you can do this later. But we're in the Office store. So this add-in is in the Office store. So do a search for machine learning. And trust it, because you're here, you trust Microsoft. And you can select the Titanic Survivor Predictor. So we did the same thing. All you have to do is add a web service. You can add the URL of the model that you just built and the API key, and you can do that in Excel. So we have our add-in, and going back to our original question, would you board the Titanic? Well, let's test it out. So we have some sample data here, but we're going to get rid of a few rows. And we're only going to test a few passengers. So let's talk about two passengers that were on the Titanic, Leonardo DiCaprio and Kate Winslet. So we had a third-class passenger. He was male. He's probably 28 years old. Didn't travel with any siblings. Didn't travel with any children. He gambled, and he won the ticket. He didn't pay anything for the ticket, but let's just say it cost $7 and $11. And we'll have him leave from the same port as Kate Winslet. Kate Winslet traveled in first class, female, probably 23. Didn't travel with any siblings, traveled with her two parents, and probably paid a lot for her first class ticket. So what I'm going to do now is send this data up to the model that we just built and see what it responds with. And so you can see the results come back. Leonardo DiCaprio did not survive, Kate Winslet did. If you watch the movie, you know this is a pretty good model. So this is just a funny example, but what we do with something like this, and what you could do, is just in your organizations, you could imagine building a sales forecasting model. If your analysts are living in Excel, they have all their data in Excel, they could send that data up to the forecasting model, get responses back. You can do customer churn. You can do whatever data you have in Excel. You can now integrate an Azure Machine Learning model into here. And then let's say people want to play with a model. Let's say you want to do some what-if analysis. Then you can change things around. So let's see what determines whether people will survive or not. So given what if Leonardo DiCaprio was in first class? Didn't seem like that would have made a difference. What if he was older, like 50? Still doesn't seem to have made a difference. What if he was female? OK, so now you can start seeing what are the factors that are affecting the predictive model. And you can start doing things like this, again, in your sales forecasting. This is my forecasted sales. What do I need to change? What variables do I need to change in order to increase my sales? Or this is predicting customer churn. What are the things that are going to affect and keep my customers? And so that's the power of machine learning, so that you can take this and have the foresight to be able to take action on it. So this is the Excel add-in with Azure Machine Learning. And I'll show you some things that we're also planning on doing with Power BI. So in this case, I have a Power BI, I have an energy dashboard. This data is coming in near real time every 5 minutes. This is electrical demand generation, electrical demand from the state of New York. And so you can see here the different areas of New York. And here is the forecasted demand and actual demand. So imagine, again, something like this, when you can connect it to your machine learning model, and now you're an electric company, and you see this is my actual demand, this black line here, and this is my forecasted demand, this red line here. So if people can see this kind of data, this is what I'm forecasting, then they can start taking action with that data. Do I need to bring in, be able to bring up more capacity so I can meet that demand? Can I save some money so that I don't need to give as much capacity? So these are things that we can do in Power BI that you can do if you put your data into a storage location. You can read it from Power BI. So Azure Machine Learning can write data to storage. Or you can do things like Azure Stream Analytics that you could do to directly pump data into Power BI. And also, we're working on some more integration with Power BI. Did you guys see the screens out there for how old the perception, the screens out there that estimate whether or predict whether you're male or female, kind of like your age and stuff? Yeah, so that's the how old dashboard. And that also comes from the gallery. So let me go back to the gallery. So talking to all the developers here, the how old website, let me just go to, if you're familiar with the How Old robot, this is something that we launched at Build about a year ago, where basically you can upload a picture and it'll do an estimate of your gender and of your age. And so outside we have something that's similar with some more advanced capabilities. But those APIs all came from here. So these are APIs that you can take advantage of right now. If you have an image that you want to send up to be able to detect a face, you can do that from this. We now do predictions on emotions, do predictions on a lot of things that you could do right now. Here's an example of the kinds of insights that you can get from Power BI. This is a near real-time dashboard of the How Old robot. Not the thing outside, but basically the How Old robot that we've launched that's been out there for a year. So we've had about 90 million users. 616 million photos have been uploaded. In the last 50 seconds, we had about 52 photos uploaded. You can see here, photos per second. One of the things that's most interesting to me here is just the distribution of the users that use it. So you can see here in our Just a Kid category, we have about 40 faces that were predicted as female and 7 as male, and this is changing because it's pretty much near real time in the last 2 minutes. For the 20-year-olds, more females than males. For the 25-year-olds, it's starting to get a little more even. Now you start seeing something interesting. 35-year-olds, lots of males are sending up their pictures. 40-year-olds, a lot more males than females. 65-year-olds, again, a lot more males than females. And again, this is just to illustrate the power of having some real-time dashboards that can do some updates, and you can see some insights based on this. So now we know the types of users who are using our products, and we can start targeting them and just basically better understanding them. And so this is just the How Old dashboard. And so basically, in terms of all of this, bringing it all back together. Bringing it all back together. To go from hindsight to foresight really requires some form of data science, some form of machine learning. And so for all the analysts in the house, it's really easy to be able to go to and use Azure Machine Learning. Let me just go back to the slides. We also have an edX course to teach you how to use machine learning. And so you can go to azureml.net and just try out the studio for free. Again, you can try it without any sign up. You can try it in anonymous mode and guest access. If you have a Microsoft account already, you could try it also for free. You can start building your first models. Go to the gallery, pick a template, do churn, do sales forecasting, do credit card risk detection. Open it up in Studio, run it, publish an API, try using it in Excel. And this is really helping you just start, not starting from scratch, but starting with something. And then either go to the edX course, teach yourself more about how you can do some more predictive analytics with data, play around with it, really, because we all love playing with data and just doing things with data, using it in Excel, sending it around, and then ultimately being able to get to a place where you could now have this, again, last mile, going native with the natives. You have something in Excel that you can email to someone else on your team. They can open it up. They have all the sales figures. They are able to run a predictive model and forecast sales. And so this is something going from hindsight to foresight. And once they have that, they can take more action based on that data. So some of the other sessions that are interesting, 2 o'clock, there's the power of R in Power BI. So we're working with a Power BI team to be able to do R visualizations. If you have an R script and there's visualizations there, they're going to talk to you about how you can do that and visualize it on a dashboard. So you have the amazing capability of everything that's available in R and putting it onto Power BI. And then tomorrow morning at 9 a.m. is something also interesting, using EEG and an Azure Machine Learning model. So basically what happens is there's some sensors that you could put on your head. Those brainwaves, that brainwave data is then sent to an Azure Machine Learning model, and you can do a prediction on whether you're lying or not. So it's just some of the fun things that you can do with Azure Machine Learning. So with that, thank you very much for your time. If you can find me on Twitter. So Ted Win Wei. If you have any positive sentiments, send it to Twitter. Negative sentiments, you can email me. But thank you very much for your time. So we do have some time for questions. So feel free to stick around if you have any questions. Please ask. Be more than happy to talk to you more about how we can do advanced analytics and machine learning. OK. Yeah, so the question is about performance. And so sometimes you'll have data sets with lots and lots of data. Performance will vary, but we're talking in the order of milliseconds, depending on the complexity of your model. So if you're doing something that is super complicated, it might take a couple more, like 100 milliseconds or so. Something that's very fast, we're talking order of milliseconds. So we have a quick response for like Internet of Things scenarios. We also have what's called batch processing. So let's say you have a ton of data that you just want to do predictive modeling on. You can do it in a batch mode, get your responses back, and then you can do that data. Yeah, so great question. Yes, sir? Yes. Yeah, that's a great question. So the question was, how do you choose your algorithm? How do you choose your classifier? And so what we do is we give you all the tools. We give you all the different classifiers of how that you could just bring in, and you can tweak the parameters for. We also have a parameter sweep module that you can try different parameters on and pick the one with the best results. So I think that's something that we do want to work towards in the future, to be able to recommend something, but we're not there yet. So the last time we tried to do some recommendations, we came up with Clippy, and so you all know how that came out. But in this case, what we want to do is you could pick the models that you want, you can look at all the results, and then you can choose the actual algorithm that you want to keep in the end. Yeah, thank you. And yeah, another question.
What type of release schedule is Azure ML on as far as releasing?
Yeah, great question. So what kind of release schedule is Azure ML on? This is something that we release every couple of weeks. So I think the Power BI team has been very great. They're on a very, very solid release schedule. We're also a service that's running on Azure. So every couple of weeks, we have a refresh with different bug fixes or functionality. Yeah, so great. Thank you. Yeah.
So it seems that the data flow from ML to Power BI is like pretty much a one-way data flow.
Uh-huh.
Then the more that you push it to Power BI, is there a time we have like this two-way data flow, like build stuff in Power BI,
Right.
back to the ML models to do stuff on top of it and push it back to your data? Is there something on the roadmap that talks about a two-way data flow?
Mm-hmm. Right, that's a great question of basically a two-way data flow. So the question is, we have data that goes from Azure ML to Power BI, but can it come back? And so, yeah, that's something that it's a little bit more involved right now, but basically what you can do is the outputs from an Azure ML web service can go into Power BI. You could set that up, or Power BI can read from a blob store or SQL, and then you can write data back into that SQL, or you can pump it to an Azure ML web service. We also support retraining. And so let's say you have a web service in production. Right now it's doing your elevator prediction of whether a component will break down. We support retraining so that if you have more data and then you test it out and it seems like it's better, you can then replace that model and retrain it with the improved model. Yeah. So always learning and always trying to become better. Yeah. Okay. Any other questions? Oh, yes, sir.
Your machine learning, such as logistic regression, you have to train the area to go in and see p-values like significant or
Yeah, I'm sorry. So could you repeat?
P-values for the individual independent variables.
Right.
Select which ones to include in the model, which ones to remove.
Yeah, so like a lot of the feature engineering, the things that we want to do, that's not in there yet, but then that's something that we do want to include in the future. Right now, if you do pick a model, let's say you pick some algorithm, it does give you different weightings of the different features. And that could help you in your feature engineering to determine which features are the most important ones that you want to do. In terms of the actual results, if you wanted to compare the output of this model with that model, you could take the data, compare the results, and then you can see if one is statistically significant better than another, and look at those p-values there. Yeah. Cool. Okay, any other questions? Yes, sir. That's a great question. So the data set that was used to build the Titanic model, you could source data from a lot of different places. You can source data from Azure, Azure Storage, Azure Blob, Azure Table. If you have an HTTP, if you have a URL where that data is living somewhere in the cloud, you can do it. We're also building a connector to an on-prem SQL database. So if you have data in SQL, then you could connect that to Azure ML. So the data can go up there, you can train your model, and then you could build a predictive web service with that model. So great question. Any other questions? Okay, great. Well, thank you very much. Thank you again for your time.